Hi, myself G. Rajan. My metric number is A24KAA5016, and I'm from Expert Group 5. And my group members are Haikal, Ashraf, and also Shakira. We are going to explain about Markintosh and also JKR props. Okay, first of all, we are going for the introduction, which is definition. Our definition is the Markintosh or JKR prop is a simple field test in a geotechnical engineering. It's a lightweight penetration test where a rod is driven into the ground and count the blows needed to push it into the soil, and also commonly used by the Jabatan Kajaraya, which is JKR. And also our objective for this Markintosh the JKR prop is to determine soil strength at different depths to estimate the soil consistency of the subsoil layers and to help decide either the soil is suitable or not for the construction. Okay, we are going to move on for the equipment, procedure, and also the principle that we use. The equipment that we use are the steel rods with a cone tip, usually 60° for JKR prop, and also standard hammer with weight of 4.5 kilograms, measuring scale to record the penetration depth, and also the extension rods if deeper penetration is required. After that, measurement. The measurement is the result is expressed as blows per 300 mm penetration, which is under the Newton value. And also this value represents the resistance of the soil to penetration. Next, we are going to move for the test procedure. The prop is placed vertically on the ground surface. A 4.5 kilogram of hammer is dropped freely from the height of 300 mm. The hammer drives the cone into the soil. The number of the blows required for every 300 mm penetration is recorded. The test is continued until the hard layer is reached, which is 400 blows for 300 mm, or maximum length, which is achieved until 15 mm. Okay, next we are going for the calculation. When we go for the calculation, the main thing we are going to use are the unconfined compression of the clay. We are looking at the table for that. When the 0.2 Newton, we are going for the calculation. When we go for the calculation, the main thing we are going to use are the unconfined compression of the clay. We are looking at the table for that. When the 0.2 Newton, we are going to use for the very soft, and also unconfined compressive strength we'll use for 0 to 25 kPa, or JKA Markintosh prop will be 0 until 10. This is for the first one. And when we go for the most stiffest one, we will go for from 15 to 30 Newton. The consistency will be stiff, very stiff. Okay, we are moving along for the allowable pressure force end. The most medium one, we will look for it. The most medium one, which is 10 to 30 Newton. That's the medium one. Allowable soil is 80 to 280 kilopascal, and also JKR or Markintosh prop is around from 30 to 80. That's an example. And after that, we are moving forward for the next slide, which is application, advantage, and limitation. What's the application? Mainly the preliminary site investigation, road and pavement design, low-rise buildings, and identification of the soft soil areas, and also slope and embankment assessments. That's the main application we are using for the Markintosh and also JKR prop. After that, advantages: low cost and economical, fast and simple to perform, portable, no heavy machinery required, and effective for quick soil screening. Lastly, the limitations: low accuracy. It's a low accuracy one. No soil samples obtained. Limited depth will be under 15 meter. Not suitable for hard and dense soils. And also human error. That's the most limitation we are concluding from this. And when we move forward for the last one, which will be conclusion. What's the conclusion for this? The Markintosh or JKR prop is a simple and effective in situ test. What's the conclusion for this? The Markintosh or JKR prop is a simple and effective in situ test that is highly suitable for preliminary site investigation, especially in a soft to medium soil conditions. The test provides a quick estimation of a soil strength based on the penetration resistance, which is useful for early stage assessment in the engineering projects. However, the results obtained are approximate and less accurate. It's recommended to combine the test with more reliable methods, such as standard penetration test, which is SPT, or cone penetration test for detailed analysis and also final designs. And that's all from us, from Expert Group 5 and myself, G. Rajan. Thank you so much.